So we've arrived at the site of power rings. So power distribution is the most significant challenge of floor planning. How do we distribute the power ground voltages evenly throughout the design? How do we robustly connect all the wires of a certain PG net? How do we make sure they're shorted together really well? So these are questions, and one of the common methods to solve this is to use rings. It's something that wastes a little bit of area, but it makes floor planning a lot easier. So what we're going to do is make this ring that goes around the macro. So this is a horizontal layer and a vertical layer, and they're connected by a wide like a big array of vias over here. And once we do this, if we have a connection of power and ground, they're spread around the macro evenly, and they provide easy targets for connecting stripes and PG pins. So if we have a stripe like going across here, it has a good place to connect to and short everything together, or maybe standard cell rows. They have a good target to connect to. So rings are a really easy way to make things, DRC ready, and that's why we had in the floor planning command and the possibility to move the core area away from the IO area. So the pins are going to be over here, the core is going to be over here, and we have room to put these rings over here. However, do note that this wastes area, and so you might not always want to do it, but you'll have to deal with fixing DRCs in a much harder way. Okay, so how do we do that? We use the add rings command or the add rings form. Okay, and there are all these options to make the ring. So add ring minus type core ring. So that's going to make the ring like this, because we could be making rings, for example, around some sort of an SRAM macro or something like that. Which nets we're going to be making, what the width is of the rings, what the spacing between them is, the offset from the side is, what metals to use for the bottom, top, right, and left, or we can define it within this form over here.
I'm skipping all of this, and we'll be discussing it in a later video when we go into larger macros that have macros inside them and so forth. But right now, what we're going to do is I'm going to show you how to put a ring around the floor plan. So rings, if I want to, again, go using these forms to get my setup, see what the commands are that it spits out and so forth, and then configure them and keep them in my script. What I would do is I would go here to the floor plan, and in this power menu, I have power planning, and inside there's add ring. And what I'm going to do is I'm going to add a ring around the entire design over here, the entire macro. I could possibly not do such a thing, and I could put rings around every single one of the macros inside. We'll see that again in the future video. But again, this is a form with a lot of options over here. They can say which nets I want to use, for example, VDD and ground, add them over here, and then how I want to put them, what the width is, and so forth and so on, and it will make me rings around my design. So you can play around with many of these options. There, again, add rings is another type of these commands that has quite a lot of options. I already put some sort of a default type of thing inside, and I have add rings. The type of the ring is a core ring, so there are going to be other types of rings like around macros and so forth and so on. What the nets are, okay, I want to center it, go around the core. What layers to use that I have defined in my definitions over there, what the width is, what the spacing is. So these are things that I actually defined inside my SM floor plan defines over here. So I said what the core ring width is, core ring spacing, core ring layer, and so forth and so on. I'm going to now run that, and that could take longer than it just did, but we really have a tiny design. So what I got here now using that command is I got a ring of VDD over here in metal 3 and a ring of ground in metal 2. And what these rings actually do for me is they provide a nice landing target for my rails, my follow pins. So the follow pins are going to be the metal 1 pins that are going to go across the rows over here. And to make sure that they're connected to each other well and they have a good place to kind of stop, now that I have these rings on the side, my follow pins are going to be able to extend to them and throw vias up here and provide a nice connection and a nice short between them. That's not the only thing we're going to do. Then we're going to put stripes and maybe build a whole power mesh on top of this. But it's an easy way to kind of start that type of a thing when you may have IOs or something else outside here. You don't necessarily need to use such rings, but it can help us remove all kinds of DRCs at the expense of some area, as we can see here. So, and it kind of gives a like basis of spreading our IR drop around the whole thing, even though that's not 100% true.
Next, we are going to connect the PG pins. So the connection of the PG pins is called special route in Innovus, or SRoute. Okay, so what does it do? It routes follow pins. Follow pins are the M1 VDD or ground rails. It's not always going to be N1 in every technology, but usually that's what we look at. So these are the rails that are inside the standard cells. They're called follow pins. Okay, it's going to connect the PG ports to the VDD and ground rails. It's going to connect macro PG pins to VDD and ground nets. So it does a lot of things, this special route command, and it's a very powerful command that you're going to have to use and run. Okay, so we have this SRoute form, and you see that all those different things that are the different options or types that you run with the route special command, they're here: block pins, pad rings, floating stripes, pad pins, follow pins, and secondary power pins. And you should probably run them one by one and not all together, so you can make sure that each of them did its job very well. Okay, so for example, if we want to go and connect the core pins to the nets VDD and ground, that's going to run the standard cell rows, the follow pins. So we do route special minus connect core pin minus nets VDD and ground. The same would be done by clicking follow pins over here, adding nets VDD and ground over here, and doing OK. So it's going to route these guys. So this is going to be a very big command. When we have IOs and we have macros, I'm going to show you what the different options are. Right now in our simple block, all we're really doing is routing these core pins. The check DRC command is an Innovus built-in command that really checks DRC. The form is called verify DRC, which used to be the name of the command in older versions. And the form, as you can see, either you can run DRC on the entire area, or you can specify an area. You can select things and select the area, and you can also not check all kinds of rules, and that will speed things up, because on a big design, this can take quite a long time. Or we can write check DRC and give different command line options to set these types of rules, and it will run for, again, if it's a tiny little design, it will run real quickly, but if it's large, it will take a long time, and divide it maybe into different cores or different areas, and it will be running DRC, and in the end, it will tell us how many violations we found, and we want it to have 0 violations. So I just want to note that DRC checking is based on the tech-left, so it's not based on something like a DRC rule deck, and it's not sign-off quality DRC checking. So we're going to have to run DRC with a sign-off quality DRC tool when we want to run sign-off. But this is something that is done throughout the flow and shows us blatant DRCs that can be shown in the tech-left. I also want to mention that if you're running early on a new type of design, or you haven't set up your tech-left correctly, you will come out with all kinds of DRCs, which is going to be really hard to fix. There can be thousands and so forth. So it's really important that the flow is settled to get the tool to actually route and so forth with DRCs in mind. Okay, so once we do have violations, what we're going to do is open the violation browser. So the violation browser is one of the tools that we have, and it's a form that tells us the different types of DRCs we have. These are all errors. It's not just from check DRC, it's also from check connectivity and other types of checks that we may run throughout the design. And we can go through and see what they are, and we can zoom to the different violations and clear violations and do all kinds of other things like that. We can also load violations in from, for example, a sign-off tool. So there's a lot of options here that we can do with the violation browser. Sometimes it's very hard to understand what is going on here, but I guess it's something that you get used to. Now, at some point you may want to delete all the markers and run DRC again, or just keep on with our flow. So that's with the delete DRC markers command. It will delete all of these guys. It doesn't mean that we solved the problems. It just means that it doesn't have all these markers and X's around our GUI.
The next step of our floor planning is going to do what we call special route. So special route are all kinds of routes that we do at the floor plan level before we do our detailed routing, before we do our placement actually. And again, looking at the UI, we have in the route menu there is a form called special route. And the special route form has a lot of options as well. It's another one of these complex commands that has a lot of things. So again, I can choose like my VDD and ground and whatever other global nets I have that I want to route with it. And I can choose the type of special route that I want to do. And there are different types. Right now, what we're going to do actually is called the follow pins, which are the VDD and ground rails in metal 1 that are going to connect to these rings and provide us a basis for placing our standard cells. The other ones we will be discussing in the more complex lecture that I keep on referencing to. So I have a command for that in my script. Everything I want to have, as you can see in my script. So route special is the name of all the options in that form. That's the command that does it. And I want to connect to the core pins. That's the follow pins options there in the form. The nets are ground and VDD. And a detailed log is just going to print out what it actually did. So let's do that and push it over here. And it took a few seconds. Again, these things can take a long time if we have a big floor plan. It says it created 27 wires. It tells a little bit about it. I guess that we don't really care about most of what it says up here in the log, but we do care about seeing what happened in our design. So let's go back over to our design and look. We now have these nice metal 1 layers of VDD and over here, of ground, and they go over and they connect nicely to our rings, and everything looks nice so far. What I should do when I'm making my floor plan, I want to see if anything screws up at any stage, if I cause any DRCs, if I have to change something or another. So what I'm going to do is I'm going to go over and just write check DRC. Okay, and check DRC is going to run a quick DRC check. This is not the DRC check that you would get on a sign-off quality tool, but it's based on our tech left, but it should be pretty good. And what we see is verification is complete and 0 violations. If we had violations, we go back over here to the UI, and there's this violation browser. I think I can get to it through tools violation browser as well. And this violation browser is another one of these forms that we're going to use a lot. It's going to tell us what the violations are. You can click over here to see their location, and there are lots of options that we can do with the little tools over here. I think we'll see a little bit about the violation browser later, but right now we are clean. We have 0 violations, so that's good. Again, throwing all these vias and so forth, if we have a bit more complex floor plan, it can already at this stage start to cause all kinds of violations.
End caps and well taps. So end caps or boundary cells are cells that are required at the end of standard cell rows. In advanced processes, we have different cells like this at the different places like top, bottom, and the corners, etc. And these include poly, OD, NWEL, and other layers that are needed for DRC and density. So what we can see here is that we have these standard cell rows over here, and these are the end caps. So we need to put these caps at the end of each row, or boundary cells at the end of each row. We may need to put them at the bottom, and at the top there may be a different cell for the top left, top right, bottom left, bottom right, and we have a set of commands to do this. So the end caps are going to be provided on our standard cell library. We don't have to make them ourselves, but we do need to tell the tool which cell to use. So we'll do something like setDB, add end caps left edge and right edge, and we say which cell that's going to be, and we're going to then run the add end caps command with the prefix, and so all of these cells are going to have the name end cap, so it will be easy to tell them when we look at what this thing is. Okay, so those are end caps, and again, they're defined by the technology for all kinds of different reasons. The other type of kind of physical cell that we have to place now at the floor plan are called well taps or tap cells. And these are cells that connect VDD and ground to the NWEL, PWEL layers to prevent latch up. And there are DRC rules that require tap cells to appear every several microns. So we're going to use the add well taps command. We're going to say what the well tap cell is, and we're going to say how to do it. For example, this is like a checkerboard, okay, because if we have a row over here that is going to be, say, VDD, we're going to have a little bit of NWEL on top and a little bit of NWEL on the bottom. So we only need to tap it with one cell in that area, so we don't need to put them in every single row. And these are going to prevent latch up. So these are well taps. You have to pay attention that if you have different power domains and so forth, the well taps have to be specific for those power domains. These things can cause all kinds of LVS problems, so you really have to check this type of stuff out. And we have a check well taps command, which you can tell it what the DRC rule is, and it will make sure there is a well tap at the distance that we need.
So at this point, we have some more elements of our floor plan, even this simple floor plan, that we haven't dealt with yet. So they're the physical cells, which we can go over here to place, and there's this the menu called physical cells, and we see that we have add well taps, add end caps, add fillers, so add IO fillers. So we're going to right now add the end caps and then add the well taps. Fillers will only add after we finish our place and route. Okay, so if I open the add end cap form, I see that I don't have a very complex form over here. It's not as complex a type of a command. But if I do want to see what the database options are for it, I will go to getDB minus category, add end caps. And I see that there are all these options over here. Okay, or I can do getDB add end caps star, and it will show me the values of these different DBs, which some of them I set up. So you see that there are quite a lot of options over here, especially when you get to advanced technology nodes. Your standard cell library and your technology may tell you that you have to use quite a few complex options. So I am going to just run an add end caps command very simply because I already set up some of these DBs inside the settings file. So I'm going to open up the settings file right now, and we can see that there are some set DBs add end caps, which I set up inside my my library definitions for end caps and for tie cells and other types of things, and for filler cells. So I already set up some of these add end cap settings. So then I can just run add end caps. I give it some prefix, so the instance names of the end caps will have a certain name, and I will run that. And it ran this add end caps, and it inserted 16 new instances. So let's see what we actually get in our floor plan. So now you can see that over here we have cells that weren't there before. And if we want to look, if I clicked on the cell, we see that it is an instance with the name of endcap16 because I asked for a for the name endcap on to be the prefix over here. So now we see these cells, and one thing that we might want to do is just look at what's going on here and so forth. Maybe I want to remove them. I don't want to see them right now. So if I go to instances over here on the menu that allows me to select and deselect things in my GUI, I can see that there's instance types, block, standard cell cover, physical, and so forth. So these are a type of physical cell. So if I deselect this, they're going to disappear. See, they disappeared. I still have this selected, and that's why it appears over here, but I deselected them and reappear. So these are my physical cells, and now I can see that they are here. Next, I'm going to move on to the add well taps. So again, back in physical cells, add well tap, and I see that there are some options over here. In general, what we do with well taps is we're going to make sure that we have a well tap every distance that is set by the DRCs, something like 25 or 30 microns. And we can do it in all kinds of ways. We can just put one every 20 or 30 microns, or we can put one over here and one over here and one over here and one over here, because we actually the N well is shared between two rows. So one of them will have VDD and ground, and the next one will have VDD. So the N well goes between the two rows. So we only need one well tap for at that area. We don't need to waste the extra area. So there are different types of options. And going back to my my commands I already have written out. So add well tap. I give the well tap cell that is defined. Checkerboard is what I just said. I won't put well taps in every row, but I will kind of stagger between them in a checkerboard, so I save some area, what the prefix is going to be, and what the area, the interval is, and I just it gave 2 times whatever my well tap rule is, because again, I needed every other row and not every row. And then I have a check well taps command, which is going to check that I don't have any DRCs after doing that, according to my well tap rule. So I ran that, and I will go back to my floor plan over here. And now you see that I have these well taps as well. I probably didn't need the well taps next to the tie cells. It's a very tiny floor plan. These things look significant, but they're not really significant when I go to a larger design. Some of the end caps have ties inside them. They have well taps inside them. Some of them don't. So you just have to adjust this according to your technology and standard cell library. But we need to have these well taps, and then I can actually go and run this check well taps, giving whatever the well tap rule of the library is. And when I run it, it says there are no violations, so all is well. It should tell us, hopefully, if there is a violation in the distance between well taps, but you're going to have to run LVS with ERC to actually know if that's true, or maybe it could be in your sign-off DRC file.